so for our example number 6, we have this problem. And in this problem, we are to determine the value of the force here, which is force F here. And we are to determine also the magnitude of the resultant force. So take note, to solve for the resultant force, we have to add vectorially the 200 pound and the value of this force F. Okay, so that's the resultant force. So we have to solve for the magnitude, but take note that the direction is already given. According here, the direction of the F sub r, or the resultant force, should be directed along the positive y-axis. So where is the positive y-axis? Here. Okay, so therefore this should be the location of our F sub r. Okay, so based from the data, so we have to determine the value of the F as well as the F sub r. Okay, so therefore our working equation will be like this, class. Okay, we will have to draw a parallelogram based from the given forces. So as you can see, we have made, or we have drawn, a parallel line which is parallel to our force F. We also drawn a parallel line to our 200 pound to form a parallelogram. Okay, and take note also that we have analyzed the angle on each parallelogram, or in each side of the parallelogram. So the given, if we recall, the given is only this 45 degrees, which is the direction of our F. Okay, and we have also, take note that this 45 degrees is with respect to the y-axis, while this 30 degrees is the direction of our 200 pound, which is with respect to the x-axis. Okay, so based from that, we'll be able to determine the other side, or the other angles of our parallelogram. So since this one here, class, this one here has a total of how much? This should have this should have, this one, the total of 90 degrees. Okay, 90 degrees. So since we have given here 30 degrees, so therefore this remaining angle is 60. Okay, this is 60 degrees. Now since this portion here is parallelogram, or there are parallel, so the angle here is also equal here. That's why this is 45 degrees. They are just equal here. Now the target here is this angle. We have to determine this. So this, as you can see, we can also make a parallel here, or that one, which tells us that this angle is equal here to this angle. That's why we have 30 degrees here. Okay, and as you can see, we have another triangle here, which is a right triangle. So obviously this is 90 degrees. So since this is 45 degrees, so the remaining will also be 45 degrees. That's why 45 degrees, the angle here is also 45 degrees. Okay, so let us just isolate the other portion of the parallelogram. Is because we will be applying the triangle law. So take note that this part right here, this side of the triangle, is parallel to our force F. That's why we can name this also as force F. Okay, so let us isolate this part right here, and we'll have this one. Okay, so earlier, this is the 60 degrees, which is taken earlier. This is 30 degrees right here, and this one is 75, where we have combined the 45 degrees and the 30 degrees earlier. This was the 45. Okay, so again, our given is only the 200 pound. Okay, and from this 200 pound, we are to determine the values of the magnitude of the force and the resultant of the 200 pound as well as the force. Okay, so let us start with the solving for the magnitude of force. Why? It's because class but anyway, we can choose to start with the f sub r. We can also choose to solve for the f. So it's up to you. Anyway, we will be applying what principle in this situation. Now, looking at the diagram, okay, the only given that we have is this side of the triangle, which is only one side, which is 200 pound. Okay, this is our unknown. So since we have given lots of angles here, so we should use the law of sines. Okay, and recalling the law of sines is this formula, so we can have our side A as our unknown, which is F. And since this is our side F, this one, so the angle opposite to that is this 60 degrees. And since our given is 200 pound there, so the angle opposite to it is 45 degrees. That's why we have 45 here. So cross multiplying that, we'll have this one there. So to solve for the magnitude of the force, we'll divide both sides of the equation with sine 45, and it will look like this. So class, using your calculator, if you have your scientific calculator, encode these values, and we'll have the value of force, which is a force F, which is 244.949 pound. Take note, the unit is in pound. It's because our given force is also in pound. Okay, that's for the force. Now, how about for the value of the magnitude of F sub r? There. So the same, we will apply the law of sines. Okay, the same formula that we will be using, but this time let us make our side A as our F sub r here. This one. So obviously the opposite angle there is here 75. Okay, and let us have this our side B. So we'll have here as our angle. So substituting, we'll have there. So F sub r, the opposite is 75, 200, the opposite is 45. Okay, so from that, we'll have to cross multiply it, and it will look like this. Okay, so F sub r cross multiply to sine 45, and the other one 200 and sine 75. And we'll divide both sides of the equation by sine 45, and it will look like this. But the same, use your calculator to solve for this value. Again, kindly correct, this is F sub r class. This one, this should be F sub r there. So using your calculator, the value will be that one, 273.205 pound. Okay, and that's it.